Hey guys, it's Charlie from EngineerExcel.com. Today I'm going to show you how to solve an implicit equation in Excel to calculate the tension in a catenary cable, so stay tuned. A catenary cable is a cable hung between 2 points that are separated horizontally by some distance. The only load acting on the cable is its own weight. If we take a section of the cable and analyze the forces acting on it, the free body diagram looks like this. At the lowest point of the cable, the tension force is horizontal, and the tension at this point is related to the geometry of the cable by this equation, where T is the tension, W is the weight of the cable per unit length, Y0 is the height of the lowest point of the cable measured from some reference, and X and Y are points that the cable passes through measured from that same reference. Now, if we know the geometry and mass properties of the cable, this equation could be solved for the tension. But that's difficult because T is an implicit variable, meaning that we can't rearrange this equation to put T alone on one side of the equal sign. Instead, we need to use root finding to get a solution. In root finding, we rearrange the equation to put 0 on one side of the equation. And then we use some iterative method to find the value of T that causes the right side of the equation to be equal to 0. There are a few different ways that we can do root finding in Excel, but the quickest way is to use goal seek, and today I'm going to show you how to do that in Excel. In the spreadsheet, I've already set up places to store the inputs and the outputs. The first input is the weight per unit length. We'll call it W, and we'll input a value of 20 newtons per meter. Next is the height of the lowest point in the catenary cable. We'll call that Y_0, and give it a value of 6 meters. Next, we'll enter the known vertical positions and horizontal positions. The known vertical position is Y, and we'll give that a value of 18 meters. Finally, we'll end with the known horizontal position X, and that has a value of 45 meters. Now we can move on to entering the outputs in our spreadsheet. Tension is technically an output, but here we're going to enter it as just a value in our spreadsheet. Later on, we'll use goal seek to automatically iterate and find the correct value of the tension. So we'll call this value T, and we'll enter an initial value, which is just a guess value of 1500 newtons. Now before we go on into entering the equation, I'm going to make it easier to understand this equation in Excel by assigning names to the values in the cells that are going to make up the formula. To do that, I'll select all the cells containing the names as well as the values, and then in the Formulas tab, I'm going to select Create from Selection, and then in the window that opens, making sure that the left column box is selected, I will click OK. Now if I click each of these cells containing the values, we can see that they've been assigned names, such as W, Y_0, Y, X, T, and so on. Now when we go to enter in the equation for which we'll try to find that root, it becomes very easy to type in that equation. We can just refer to the values in the cells by using their names. So the equation is T divided by W times the hyperbolic cosine of W divided by T times X plus Y_0 minus T divided by W minus Y. And right now that formula is not equal to 0 because the guess value that's been entered is not the correct value of the tension that satisfies the equation. So we'll use goal seek to iterate through values of T in order to find the correct value. So goal seek is a tool that's found in the Data tab by clicking on What If Analysis and then choosing goal seek. In the goal seek window, we need to select a cell containing the formula. That's the cell that we want to set equal to some value. So I'll select cell D10, which is the one that contains our formula for the catenary cable tension equation. To satisfy the equation, we want to set the value equal to 0. So I'll enter that in the second field. Then finally, the cell value that we want to change in order to set cell D10 equal to 0 is the value containing our tension, because that is the value we want to change in order to satisfy the equation. Once all those fields have been filled out, we can click OK. Goal seek is going to run and do its thing, and the value that it achieves is approximately 0 with some amount of error. We see this about 1.1 times 10 to the minus 5. And the tension that solves the equation is 1,726 newtons. This video has been brought to you by EngineerExcel.com. If you'd like to learn more about how to solve your tough engineering problems in Excel, sign up for our free Excel training for engineers using the link in the description below, or subscribe to the channel for more videos just like this one. That's all for now. Thanks for watching and talk to you later.